Okay, use the information diagram and proof to fill in the blanks. Given that D is the midpoint of segment AB, E is the midpoint of segment AC, and segment DB is parallel to segment CF, prove that segment DE is parallel to segment BC and that DE equals 1/2 the distance of BC. Okay, so I normally duplicate this tab. However, the last couple of times it hasn't helped out at all. So I'm going to just first jump into context clues to see if we can answer it quicker that way. So right here I'm jumping to where I see the blank 1. The statement is that angle A and angle FCE are blank. So here's angle A right here and angle FCE. So here's angle FCE are blank. So here's our angle A, angle FCE is right here. Well, first I'm noticing that it looks like a sideways Z, and in one of the previous videos this was a tip for an alternate interior angles theorem. So let's just verify that we have all the information. So we want perpendicular parallel lines, so it says line DB right here. Here's our line DB. It's parallel to CF. So yes, we have perpendicular lines with the transversal. They are on opposite sides of the transversal and they are inside. So it does satisfy all of that. So it is alternate interior angles. So that is what 1 is, alternate interior angles. Right there. So then now we're going to jump to number 2. It is stating that triangle AED is congruent to triangle CEF. Okay, before we do that, I'm going to go back through these statements and see what is given. So we have triangle AED right here is congruent to triangle CEF right here. So in the statements, first we have that angle A is congruent to FCE. So angle A is congruent to FCE, which is this angle. So we have an angle and its corresponding angle so far. Then it's stating that angle AED is congruent to CEF right here. So we have angle AED, so right here, and angle CEF right here. So we have another pair of corresponding angles. So here's our 2 barbells. And then it's stating that right here, segment CE is congruent to segment EA. So segment CE from here to here is congruent to segment EA. So we have an angle, side, and an angle, the corresponding side, and the corresponding angle. So we have angle, side, angle to prove that those triangles are congruent. So angle, side, angle congruence theorem is how we stepped through that. So again, we just reviewed the statements that were given there and made sure we marked it so we could see what we had. So now we're jumping to this third one. It says that segment DE is parallel to segment BC. The reason before is quadrilateral BDFC is a parallelogram. So if one pair of sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So we have parallelogram BDFC, and this is stating that DE is parallel to BC. So let's see what the relationship is there. Well, it's stating that DE is parallel to BC, which is true because point E lies on this side length right here from D to F, which lies on the parallel line to BC. So any part of this line segment DF would be parallel to BC. So since DE is a segment right there, it is still parallel. So that is based on just the definition of a parallelogram, because parallelograms have opposite sides that are parallel. So that's our definition, and I used that context clue right here, parallelogram. So that's how I would step through this proof and answer the questions.